Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Hey Alexis, what are you doing?
I'm boiling some water for pasta. It's so annoying that it takes so long though.
I know, right? Did you know the science behind boiling water is called thermochemistry?
Thermochemistry? What's that?
Thermochemistry is the study of energy changes that occur during chemical reactions and changes in state. Every substance has something called chemical potential energy. This is the energy stored inside of its chemical bonds. The kinds of atoms and their arrangements in the substance determine the amount of energy stored in the substance. During a chemical reaction, a substance is actually transformed into a new substance with a new amount of chemical potential energy. For example, in this gas stovetop that you're using the stored potential energy the gas contains to create your fire and the heat produced.
Oh wow, that's so cool. I never knew it was behind creating the fire in my gas stovetop. Well, that's cool and all. I just wish my water would get hotter faster. I'm really hungry.
Well, that's not exactly right. As the water absorbs more energy, the temperature isn't always going up. During phase changes, the temperature stays at the same level until it completes its transition into a different state of matter. In order for your water to start boiling, the water needs to absorb enough energy to get to the point where it starts becoming steam. Here, the temperature will stay consistent until it fully becomes steam, although hopefully you won't be making any steam since you won't be walking away from your pot, right? Here, let's take a closer look at the math that helps determine the amount of energy needed to heat up water. This is the basic equation, Q equals mc delta T, where Q is the amount of heat, m is the mass of the substance, C is the specific heat of the substance, which is the amount of heat it takes to raise the temperature of 1 gram of the substance 1 degree Celsius, and T is the change in temperature. To measure the amount of heat or energy, we use the basic SI unit, joules.
You mean this joule?
No, not that joule, Joule. Or you can use calories, which is the energy it takes to raise the temperature of 1 gram of water by 1 degree Celsius.
Well, I don't know. I've been trying to cut back on calories since prom's coming up.
No, not those calories. Well, they are related. You're thinking of nutritional calories. 1 nutritional calorie equals 1,000 calories. Kind of crazy, huh? Imagine how many of those calories you're consuming with 1 bowl of pasta.
Well, maybe eating some pasta wasn't my best idea before prom.
Maybe not. Anyway, another unit of measurement is kilograms, which is the SI unit for mass. For small things like a chunk of gold, we sometimes convert kilograms into grams by multiplying by 1,000. For temperature, we use the unit Kelvin. 0K is absolute zero when there is no molecular movement. In order to convert Kelvin to Celsius, we add 273. Now that I've given a bit of background for our formula, let's try a problem.
In order to find the amount of heat needed to be added to this water to get from negative 23 degrees Celsius to 152 degrees Celsius, we look at the beginning of where we start. We start at negative 23 degrees. So we multiply the mass of the water, which is 3.22 grams, times the specific heat of ice, which is 2.06 joules a gram, times the amount of temperature needed to get to 0, which is the freezing point of water, so times 23. That's our Q1. For Q2, we're looking at that consistent heat. So that would be the mass, 3.22, times the consistent heat of fusion, which would be 334. Then we look at Q3. This is when it's water. So that would be 3.22 times 4.186, which is the specific heat of water, times 100, because we have to get to 100 degrees Celsius when it starts to boil. From there, we look at the consistent heat there, which would be 3.22 times 2,260. Lastly, we look at Q5. This is where it's steam. So we go from 3.22 times the specific heat of steam, which is 2.03, times 52, which gets us to 152 degrees Celsius. All added up together, and that would be 1,096.3876. For Q1, 3, and 5, we use the equation mc delta T. For Q2 and Q4, since it stays at a consistent heat, we multiply the mass by the specific heat of either vaporization or fusion. Oh, you know what would go great with this? Some lemonade.
Oh, yeah.
But wait, my ice hasn't frozen yet.
I know why. Before we talk about your ice, let's talk about the two kinds of chemical reactions, exothermic and endothermic. Endothermic takes in heat, just like your water needed to begin to boil. Exothermic releases heat, like freezing water. In order for your ice to freeze, it needs to release enough energy to complete its phase change.
Wow, I never thought that everyday activities like freezing and boiling water could actually be chemical reactions with lots of components to them.
Well, science is everywhere.
But to be honest, it's Memorial Day weekend, and I don't want to think about Mr. Dove's test on Monday.
Same. Hey, can I have some of that pasta?
How about you go make your own, since you seem so interested in the process anyways?